Now in this particular session, we would be looking at permutation, the basics of permutations. Now coming to permutation. First we're looking at the definition, then we'll be going with an example. Coming to definition. Permutation of n different objects. Okay. A permutation is an arrangement of all or part of set of n objects with regards to the order of the arrangement. Just would be doing arrangement using a permutation formula. Now, the number of permutations of n different things taken r at a time is given by NPR, where NPR is equal to n factorial by n minus r factorial. Okay, if you have n different objects, you want to arrange it in r different sets, then it is given as NPR. If you consider one example, like you have three objects A, B, and C, and you have to set in three sets 1, 2, and 3. So here we can see that n is equal to 3 and r is equal to nothing but 3. In general, if you consider how can we set ABC in three sets, it can be done in A, BC or A, CB, then B, AC or B, CA. Another one is CAB or CB, right? So how many we got it? It's nothing but 6, right? By using a formula of directly we can say it. It is given as NPR. So it is nothing but 3p 3, which is equal to 3 factorial by 3 minus 3 factorial. Okay, you have to remember this one. 0 factor is always 1 and 1 factorial is also 1. Okay, so we get 3 factorial, which is equal to 3 into 2, which is equal to 6, right? Same thing we got. Now if you consider there are 4 objects like A, B, C and D. Okay, and you have 3 sets. You have to fill in 3 sets. So we can see that n is equal to 4 and r is equal to 3. How can we arrange it? As nothing but we consider A here in the first position. In the second and third, we can place either of B, C or D, right? So we can write as A, B, C or A, C, B or A, C, D, A, D, C. Then we can arrange A, B, D or A, D, B, right? So total we got 6, right? Similarly, if you arrange B here and you have to arrange in the two sets A, C and D. Okay, then we can arrange in the form of B, AC, B, CA or B, CD or B, DC or B, AD or B, D, right? So it becomes nothing but 6, right? Similarly, if you set C here, in the two sets we can arrange A, B or D. Then also we get 6. And if you consider D in the first position and second and third, if you consider they are A, B and C, then you can set in 6 different ways, right? So totally how many you get it is nothing but 6 plus 6 plus 6 plus 6, which is equal to 24. But is a long method, so we use a shortcut method using a permutation. This is given as 4p3, which is equal to 4 factorial by 4 minus 3 factorial, which is equal to 4 into 3 into 2 into 1 by 1, which is equal to 24. We know the permutations, right? NPR is equal to n factorial by n minus r factorial. Factorial of a positive integers, you have to know it. Okay, positive integers are nothing but n should be greater than or equal to 1 or n should be greater than 0, then it is not in a positive integers. Okay, now we know that n factorial is equal to nothing but n into n minus 1 into n minus 2 into so on until we get 3 into 2 into 1, right? The basic thing you have to remember the factorial values from 0 to 10. We know that 0 factorial is equal to 1, 1 factorial is equal to 1, 2 factorial is equal to 2, 3 factorial is equal to 6, and 4 factorial is equal to 24, 5 factorial is equal to 120, right? And 6 factorial is equal to 720, 7 factorial is equal to 5040, and 8 factorial is equal to 40320, and 9 factorial is equal to 3628880. Okay, and 10 factorial is equal to 3628880. Okay, you have to remember the factorial values from 0 to 10. Okay, now coming to the question. The question is, in a race there are 7 horses. Okay, and how many different orders can the horse finish the race? And second one is, how many first, second, and third can be possible? Okay, we'll go with the first question. They're given that there are 7 horses, right? 7 horses are there. If you consider they are A, B, C, D, E, F, and G, right? There are 7 horses. They have to reach the 7 sets, right? They have to reach the destination. So A, B, C, D, E, F, G will be starting, right? Now we have seen that the number of objects are nothing but n is equal to 7, and they have to reach 7 sets. So R is equal to nothing but 7, right? So we can use a permutation as given as 7p7, which is equal to 7 factorial by 7 minus 7 factorial, which is equal to 7 factorial by 0 factorial. 0 factorial is nothing but 1. 7 factorial is equal to 5040. Right? Now, this is a first question. Coming to the second question. Again, that how many first, second, and third can be possible? Now, in the case of A, B, C, D, E, F, and G, there are 7 objects, right? 7 horses are there. So n is equal to nothing but 7, right? Now they have to reach first, second, and third only, right? Who will come first, second, and third, right? So in this particular case, number of sets are nothing but 3. So R is equal to 3. So which of them can be possible? That's given as a using an arrangement of an set, right? So we can use an permutation. That's given as 7p3, which is equal to 7 factorial by 7 minus 3 factorial, which is equal to 7 into 6 into 5 into 4 factorial by 4 factorial. 4 factorial get cancelled, which is equal to nothing but 7 6 are 42. 42 into 5, it becomes 210. Okay, now we'll be looking at the topics of permutations. We'll be looking at the first one is nothing but words and numbers, repeated or not repeated, then repetition allowed or not, always or never together, odd or even places. Okay, in words and numbers. Now in the numbers we'll be looking at zeros and non-zero numbers also. In a circle we'll be looking at sitting in a circle and a chain or necklace. Okay, such type of problems